Hello.
Hello.
Welcome to this talk, Spring Boot 2 Web Applications. Today we're going to talk about web apps with Spring Boot 2, mainly reactive ones, because this is the new feature in 2.0, but not only. But first, as always, we always like to know a bit more about you. If you're already using Spring Boot 2 in production, raise your hand.
Okay, wow, nice.
Nice. And if you've already, in the process of upgrading to 2.0, maybe? Okay, so
Nice,
adoption.
nice numbers.
Yeah, we're collecting user data right at the start of the talk, not GDPR compliant yet. So let's start then.
Yeah, I hope your head doesn't hurt too much due to yesterday. We'll do our best to entertain you.
Right. So with Spring Boot 2, again, one of the features about Spring Boot 2 is mainly Spring Framework 5, of course. So we've got a new baseline, JDK 8. We've introduced a new paradigm, which is reactive programming, and a new web framework, Spring WebFlux. We've also added that new thinking model where we're not thinking about one thread per request anymore. So if you're using Spring WebFlux, you're not in that model anymore. You have to think in a different way. So it's a different model, but it's got its upsides, because whenever you're in an environment where you don't really in control of the latency, then this is really useful because everything's non-blocking and your application scales better. But again, it's just a different model, so it's better in some cases, it's not in others, right?
So for those components to talk to each other, we need some common API, and that API is called reactive streams. You'll get a chance, if you don't know about it, to see a bit more in details in the demo. And reactive streams is really about communication, really a very low-level API. And as you'll see in the demo, what you need is something that actually gives you operators or high-level functions to transform the data, map the data, and those are provided by an implementation. In the case of Spring Boot 2 and Spring Framework 5, we're using Project Reactor. And Project Reactor introduces two types you've probably heard of, Flux and Mono. So those are really the two classes you're interested when you start working with reactive programming. Right, so all that is a very short introduction. I'm sure you've seen other talks, maybe last year even, about reactive programming. So where does that leave you with regard to Spring Boot 2? Well, what we wanted to do with Spring Boot 2 is to give you the same developer experience with this new paradigm. So if you choose to stay with Spring MVC and a regular servlet-based web application, all is fine. We still support that as a first-class citizen. But if you choose to try this new way of developing web applications, you'll feel at home. You'll see that all the features that you know in Spring Boot 1 works the same way with reactive programming, and that's pretty much the intent today, to show you that with the demo.
So the use case we've chosen today is a smart meter application. So let's say you've got districts, neighborhoods, so like residential, office buildings, factories, and each building has a smart meter that sends data about the current power usage. So it's doing that every few seconds, let's say. And we're collecting all that data into an aggregator application that we have right now. And that aggregator application just collects everything and then consolidates all that into a single stream of data with everything in it. And then from that feed, we'd like to do a few things. We'd like to have an application that provides services to an operator, and that operator, she'd like to have a dashboard with the current power usage for zones. She'd like to know more depending on the zone, And she also would like to have some historical data as well, not just the live data, but something collected for the previous hours, let's say. So we've got two applications, the aggregator and the dashboard. The dashboard will process the data, store it in a database, and present both live stream and historical data to the operator for her job.
Okay.
Let's start.
All right, so we will share the code with you. As always, there's one commit per demo, so if you want to revisit one of the demo, you'll be able to do that and look at the commit message for more details. So these are the two applications Brian just mentioned. We can actually start them here. And while they do, this is the aggregator, so the one that's sending that fire hose, and it uses a dependency, I'm sure you all know, the Actuator, and WebFlux. So it's not Spring Boot Starter Web, it's Spring Boot Starter WebFlux to mention that you're interested by this new paradigm. This application is not using the annotation model to define the MVC actions. Rather, it uses a router. It uses WebFlux.fn. So you have here the programmatic router, and here the first thing with Spring Boot 2 you can see is if you define a bean of type router function, we'll detect that. And we will aggregate all the router functions and just deploy your WebFlux application with those routes. So I have two routes here. I have a fire hose and the meters for a given zone by ID. And this is a method reference. And this is basically my contract for the fire hose. As you can see, WebFlux.fn gives you a function style with a server request, server response, where you can basically process the request for a certain paradigm. So this is the endpoint. It's currently running on 8080 locally on my machine. And I'm going to tell HTTP PI it's a stream. So it has to keep the connection open because more data is coming.
Yeah. So in that stream of data, you can see that you're getting a device ID, which would be the ID of the smart meter, the current power usage, the timestamp, so when that power data was collected, and as well the zone ID. So for any zone ID, we're getting a bunch of devices sending us data with their current power usage, and we'll try to do something with it.
Right. One more thing is this aggregator application is running on Netty. That's the default implementation you'll get if you use the WebFlux starter, but as we will see quickly, you can also deploy in many other environments. So the dashboard now. So the dashboard also uses WebFlux. As I've just mentioned, for the sake of the demo today, we use Tomcat for that application. We could have used Jetty or Undertow if we wanted to, and a regular Thymeleaf starter, and something different from the data access. Because one thing that's very important with a reactive-based application is that you need to be reactive end-to-end. So you can't have some blocking code in the middle of a flow. That's especially true for data access. So that's why you'll find with Spring Boot 2 a dedicated starter that are reactive. So you'll find those for MongoDB, Redis, Cassandra, and Couchbase, I believe.
Yeah.
Yes. So in this case, we've chosen to use MongoDB. And no, I'm not going to make a joke about MongoDB, if you heard of it. Right. So what do we want to do?
So right now, we want to get the inbound data, the raw stream of data, and we'd like to create power grid samples. So the samples, the sampling part is, we don't want to store everything, the raw stream. What we want to have is a sample of data for a given timestamp for a whole district, for a whole zone. So we want to get the number of devices. We want to know the zone, when that data was collected, and the total power consumed for that given zone. And that's the data, historical data we want to present to the operator. We don't want to present the whole raw stream because it's too much. So from the inbound stream, the stream that's coming from the aggregator, we want to, in the dashboard application, we want to collect that, transform that live stream, and store those samples into our database for later usage.
So this is really a typical MongoDB document, nothing fancy about that. But the next step is that you want to be able to access that data in a reactive fashion. So in the Spring ecosystem, you'll use Spring Data. And as you can see, you'll feel very familiar because this is the repository for the Power Grid, where you extend from a reactive sorting repository. We want to be able to sort. That's the implementation we've chosen. And we have the regular method-based signature that infers the query. Mm-hmm. As you'll notice, the main difference the two main differences really is the base class, which tells it's a reactive repository, and the return type and the parameters. We won't cover that, but you can also have that with parameters. That does not return the data, but a publisher to the data in this case. So this allows us very easily to access the data within a publisher pipeline. So let's see how we can actually connect to our remote service and process the data the way Brian just explained.
Yeah. So right now we want to use a collector. So that measure collector is using a web client. So web client is more or less REST template, but in reactive world. But just so you know, you can use web client as well in your MVC application. It works pretty well. So web client is an HTTP client that you can use in your applications. And here we're saying we're fetching data from that measures firehose, so directly from the aggregator application. We're retrieving that JSON, JSON stream of data, and we're converting that to raw measures. So just the raw data as a flux of objects. So we're mapping that with Jackson, and we've got that raw feed. We're also sharing that, meaning share is an operator with Reactor, so nothing boot specific. It comes from Reactor, and here share is saying that when several clients subscribe to that Flux, to that publisher, they're sharing the same data. So it's more or less like multicast. The first one that subscribes, it's triggering the whole thing, so it's sending a request to the remote service. But when a new client asks for the same thing, we're not sending another request. We're sharing the same resources all over the pipeline, and we're just sharing data as well, so multicast. So this is pretty useful because in this application, we'd like to reuse that stream of data in several places, and we don't want to create multiple requests just to get the same thing, basically.
So remember, the main difference is this is definition of a pipeline, right? It's not doing anything. That's why we keep it here as a field, and we return it to anybody actually willing to use that data in the context of a particular pipeline. And it's very important in the case of the share operator, of course, because you need the same definition for the multicast operation to work properly.
Yeah.
So there you go. We have our measure. So now we're going to process the data.
Yeah. So if earlier when Stéphane said that Flux and Mono are nice types because they are coming with the operators as well, this is where the power from Reactor really shows, because you've got many operators, and that's where you can get help from Reactor to build complex pipeline in a reactive fashion without going totally crazy with concurrent programming, because that's really hard. So here, what we want to do is when we're getting that raw stream of data, all the measures of all the districts by timestamps, what we want to do is create a window of that raw data, but we want to have a window for a given timestamp. So we'll buffer all the data for a given timestamp, and when the timestamp changes, we're next to another window. So window until is basically here where we're basically saying when the timestamp changes, you're on next to the next window. So with that window of data, still a flux, we want a flat map. So for that window, we'll regroup the measures by their district. So we'll have some kind of map with the district and then all the measures of that district for the current window. And then later, for each group, for each district, we will create a sample. So we will collect everything and we'll reduce all those measures into one sample. So we'll sum all the power usage and add all the measures, so incrementing the device count and adding each power usage to the total power. And then we'll get, at that point, we'll get a power sample object. And that power sample, that's what we get. So in the end, that's why we're getting a flux of power grid sample. And each power grid sample is total power usage for a given time zone, for a given district, for a given timestamp. And when we have that flux, you can see we've used like a few operators, but we did some complex things in a completely concurrent, asynchronous manner, but we can still reason about it. So once we have that flux of data, we can do something with it.
Yeah, we can save it. And if you want to save it, because it's a publisher, you just pass that to the repository, and the repository will save that for you. But again, this isn't going to do anything because it's a definition of a pipeline, not actually running the pipeline. So what we want to do is when the application starts, we want the application to connect to the aggregator and start saving those data points to the MongoDB store. So for that, we use a callback, you probably know, from Spring Boot, and we simply subscribe to that flux. And that will be enough for that to kick in, that process to kick in. So let's see. It's been collecting a few things for us in the meantime. There you go. So each point here is one document in the store, where you, for one document, as Brian mentioned, you'll find for a timestamp, a given timestamp, and a given zone, the total power consumption. If we refresh, you'll see that the graph updates itself because there are new data points coming from the remote service. So obviously, what we want to do is we want to update that live. So that's the demo that we want to show you today. So I can see here I have zones / the ID of the zone, which is urban 1. We can actually see in the code how that works.
It's pretty similar to any Spring MVC annotation-based controller. So we're getting get mapping, and we're getting the zone ID from the actual request path. And we're getting data out of the repository. And then we're using a new API. It's rendering, but you can think of it just like model and view. And we're adding that data to our model, and we're rendering the zone view. And that's what we're seeing on that page. We're seeing the template being rendered and the data in it.
So we have two templates here. We have zone and index. Index is the home page of the app, and it shows the available zone. And you have a link to go to the graph for the zone. And at the moment, it's not mapped because, as you can see, there is only one. There's only one action here. So this is our wonderful error page. You've probably used that in the past with Spring Boot 1.5 or 1. I don't know what, 1.4 maybe. Maybe. So if you have a HTTP status code that matches, if you have a template whose name matches an HTTP status code, we'll use that as default. So you can find back our wonderful error page here. I can also use DevTools if I want to. So there I'm connected now to my app, and what I can do quickly is map this home page. So get mapping on /, and I need a view on index, and I need to fill it the zone. So I have my repository of zone here. And as you can see, I'm passing a flux of the zones, not the zone themselves, as you would do with a regular MVC app. There you go, and I have my page.
So, yeah, to have a quick checkpoint, so we've seen that whenever you're building a WebFlux application, you need to be reactive end-to-end. You especially need to avoid blocking I/O, otherwise it may do really bad things at runtime to your application, and it won't perform the way you want it. And there are probably a few things that you wondered about during that first part, especially the part where we're taking fluxes and shoving them into the model map, and everything goes well. So how do we deal with that? Because Spring WebFlux supports a lot of templating engines, and what happens is we are at the framework level, at the WebFlux level, Spring WebFlux is resolving asynchronously that flux, and when everything's there, it will ask the templating engine to render the view. So it's not being rendered as a stream of data one by one, but it's still being rendered asynchronously for you.
There are template engines that go beyond that. Thymeleaf 3 is really particular in that area. Daniel Fernandez, the lead of the Thymeleaf project, gave a talk at Spring I/O last year about this. Mm-hmm. So it's on YouTube if you want to know more about this. We're not going to cover it as part of this presentation. But in 2 words, there's really two things that where Thymeleaf go beyond what the template engine can do with reactive support. One is something called chunk mode. So this is the ability of rendering pieces of the view. So if you have a big view, you have a way to tell the fragments, so the size of the view, the chunk of the view you need to use, so that it renders part of the view, and then other components on the server have a chance to use the CPU, and then getting back to it and basically streaming the rendering of the view that way. The other mode, and we have a quick demo for that, is what's called data-driven mode. So it's a way in Thymeleaf to give a flux in a specific fashion. So Brian just mentioned that we will resolve the flux for you in the model. But if you use Thymeleaf, there is a way to pass a specific flux so that Thymeleaf itself will subscribe to it and render as really in a reactive fashion this time. Mm-hmm. In the next demo, we're going to show you more interesting things with Spring Data. So Spring Data K is the first major release since its inception in 2009. So there's plenty actually of projects in Springland that had a major release, not only Spring Framework 5 and Spring Boot 2, but Spring Data, Spring Security, Spring Integration, etc., etc. And so Spring Data K has plenty of non-reactive new features that you might be interested in, but we'll focus on the reactive one.
Yeah, and in that part of the demo, we'll show one thing that's interesting, because a flux, as we mentioned, sometimes in our demo, it's we're treating it as a stream of data, like data constantly coming in. But in some other parts, we're treating it as some kind of asynchronous collection. And for the power usage right now, this is more or less what we're getting, right? When we're rendering that page, we're fetching a page of data from the database as an asynchronous collection. We're fetching that flux. We're dumping that into our HTML page, and the JavaScript library is rendering the actual graph. But what we can do with the flux as well, from the database, we can treat it as a stream of data, like an actual incoming infinite stream of data. And that's what we're going to do.
Right. So the demo here is whenever the page loads, the browser will contact the server and ask for new elements. So basically it will say, OK, I've loaded the graph up to that point, So please push me updates as from that point, right? So the first thing we need to do now is we need a way for MongoDB to tell us when there is a new document that matches a certain criteria. And the certain criteria will be, it needs to be part of that zone, and it needs to be created after a given timestamp.
So we still want to have Flux as a return type, but this time we'll treat it as a stream of data. And we're also telling Spring Data that we want to use the tailable cursor feature. So it means that we want to know when a document has been added to a particular MongoDB collection. And when that kind of document has been added, we'll be notified as soon as it's been added by a new element being emitted in that Flux. So with @tailable, we're completing that story, and whenever we're calling that, that method, we'll get all the new samples added to that collection from that point in time and later, as soon as they're being added.
So it's a bit like the -- stream in my HTTP py samples earlier. It's basically asking MongoDB, please keep the cursor open. Do not close the connection. So I'm going to initiate a request and get some results matching that criteria. In this case, nothing, probably, because the timestamp I'm going to specify is now. But do not close the connection, keep it open, and notify me when new elements comes in. So we need to map that to our controller. So what we need to do is we need to simply return those objects, and we're going to use SSE for that.
So we will stream that data directly from a controller endpoint. So we'll still get zone ID as a path variable, because that's what the client will be asking. We'll map that on zone ID updates. And we're here using a streaming media type. So it won't be just application JSON, it'll be the SSC text event stream media type. And we'll directly write that to the HTTP response body. So here we'll get the, okay, you've got little templates.
Yeah, otherwise I'm sure I'm going to make a mistake for sure.
Yeah, because we don't want to, the thing is, if a client asks for that data, then we don't want to create a new connection or use a new cursor for every client. So we're creating here some kind of concurrent hash map to store and cache those cursor as they're being used by the clients. But in the end, we're using the repository, getting the flux of data, and sharing it as well.
So it's the same thing as I mentioned with the web client example, where you have to store the definition of the publisher. Otherwise, the share operator won't work, because you're going to create a new pipeline every time. So that's why we use that trick to save it to the map by zone ID.
Mm-hmm.
Right. So we have a new endpoint here that we can call, and it will stream updates for that particular zone. So now we need to update the graph live, and for that we need to connect to that endpoint. So for that,
we can add a little
JavaScript
snippet. So it's not that big. Here we're just using the raw JavaScript library. We're not using any specific library. So it's just an event source. We're subscribing to that source, and when a new message comes in, we're adding that piece of data to our graph directly. And we're using the graph library to just add that new data point, and the graph is being rendered again. So if you look here, then you can see that not only the graph is being updated as data comes into our repository, into our database, but you can see as well in our browser that we're getting messages as they come in into that server send event stream.
What's very important to remember here is it doesn't matter if you have like one browser or one operator interested by that zone, or 100 or 200. They're going to share the same backend connection with the Firehose, so with the raw data. And they're also going to share the same tailable cursor in the MongoDB store for that zone. So all the resources on the server will be shared for that particular use case. And the server-sent events are going to be broadcasted very easily. That's the only code you need to make that happen.
Right. So what are we doing now? New checkpoint? Yeah, go ahead.
Do we need to? Is there another demo after that? I can't remember now. I don't think so, right? We're good. Yeah, I think we're good.
We'll see.
I think so. So what we want also to tell you about new in Spring Boot 2 is the no, we have to show them something. It doesn't make any sense what I'm saying. Yeah, we need to show you something first. So I told you about this small demo with the Thymeleaf data-driven mode. So let's actually check out that quickly.
All right. Okay.
Force checkout is fine.
So here, what happens is you'll see that in the repository, it's commit by commit with the message and everything. So here, what we want to have is a part in the UI where the operator should see whenever something bad happens. So whenever a smart meter reports a 0 usage, for example, so maybe there's a power cut somewhere. So we'd like that. So the thing is, if you want that, you need the raw data because you don't want the samples, you just want every data from every smart meter out there. So this is where we can reuse the raw stream directly in our application, but because it's being shared by the part where we're collecting and reducing everything into samples, we're sharing that same stream of data and forwarding it to the browser whenever the browser asks for it. And we can reuse that and filter this time to only select the raw data when the power usage is 0. So we can have, like that, a stream of data for zero power usage raw measures. But the thing is, it's not really interesting here. And what we'd like to do is actually take those events, and instead of doing the rendering part on the browser, we could do the rendering part directly on the server. And that's where the reactive data driver context variable, very nice name, is being used. So we're basically wrapping that flux of data and telling the templating engine that we don't want it to be rendered as an asynchronous collection. We want it to be rendered as it goes. And instead of rendering an HTML page, we're rendering a server-send event stream, and we're rendering fragments of pages of HTML, bits by bits, and this is actually what we do.
So now what we need to do is to tell the generator that something bad happens for the sake of the demo. So for that, I have an endpoint here where I can say, for a given zone, I can say, this is the range that you need to use for the generation. So I'm going to do that. And if I do that, I can see those events coming in. Actually, if I go to zones events, this is actually the views being rendered on the server that you can see it's a stream that stays open.
So the paragraph and all the HTML tags, they're being rendered on the server using a view fragment that's in our templates. So this is a Thymeleaf feature because not all templating engines support that. But this is really interesting if you want to do some rendering on the client side, do some rendering on the server side, depending on what your application looks like.
So hopefully the power is back now. As you can see, and that's the segue with the next section, this is a Actuator endpoint we've built. So very, very quickly, because otherwise Andy has a talk later today at 12:30.
12:30.
If we show too much, it's going to be very mad. So very quickly, this is the operation that I just triggered. As you can see, it's a write operation. which means it's going to update, it's going to change, so you need to use post, basically, if you use HTTP. This is the zone, and these are the parameters that I've used for the request. And it's part of a contract that we call endpoint. And it's a way for you to define actuator endpoints very easily. And because we have this this model that doesn't rely on HTTP or JMX or WebFlux or WebMVC or Jersey, because the model is independent, we can provide adapters. And Spring Boot 2 actually runs natively now on MVC, on WebFlux, on Jersey, and with JMX. So if you define an endpoint that way, you'll be able to deploy it, regardless of the environment you're using.
And as well, because this is a reactive application, there are some actuator endpoints that you'd like to be reactive. So how do you mix reactive with non-reactive bits in Actuator? And how can you create an endpoint that's compatible and that can be exported as an MVC or WebFlux or Jersey or JMX? If you want to know all about that, we don't have time here. It's definitely this room, 12:30, if you want to know more.
More interesting thing about the Actuator, better output format. So as you can see on the right, where the structure of the Earth endpoint in this case is better structured. You've also seen in a demo, in the keynote, sorry, that there is a new way now to determine whether or not you show details. So there's plenty of nice things that you'll find in Actuator with Spring Boot 2. Right. So there is, in the context of the reactive, in the context of the reactive part, as we've told you, you need to be reactive end-to-end, but there's also the counterpart of you willing to give a custom Earth indicator for something that only has a reactive API. And you need to be able to do so without having a blocking contract. If you've defined an Earth indicator in the past, you know that the Earth indicator contract is blocking, because that was the first version. So what we provide in Spring Boot 2 now is alternative contract if you decide to go the reactive way. All right, so let's do a quick demo. I need to add the Actuator to my project. Yes, I can do this if I press the right key. Mm-hmm. Oh my. There we go. And I think I have a template somewhere. Yes. Right.
Okay. So this is an example. This is not necessarily something you should do in your production application, because the health indicators, it can be hard to really know how you should check something in your app. But here we're just showing how you can achieve something like this within a reactive application.
So I need actually to restore that stuff.
Yeah.
Because I've changed the dependency. So reactive Earth indicator, if you use Earth indicator, you know that Earth return Earth. In this case, for the reactive contract, you return a mono of Earth. And if we look at the implementation, you can see that again you can use the web client to contact a remote service, make sure the remote service is up, and then react accordingly. And if all goes well, actually I won't be able to see anything, because by default I'm going to see up. Yes.
Yep.
But I can quickly change. I can quickly say, show me all details, and that's going to be with the details. And we can find that it doesn't work because I put it outside of my package space. That's wonderful. Okay, trust us, it works. So yeah, I put the file outside of in a package, in a parent package, so component scan didn't find it. That's why you don't see it.
So yeah, as mentioned during the keynote and probably in other talks, we've totally we thought a lot about security, and we wanted to simplify it, because previously it was maybe a bit doing too much, and right now we're relying on Spring Security defaults, and but in exchange of that, we're making things easier. We're providing you with tools and infrastructure to help you configure your application with security.
So rather than having those multiple pieces that can do something for you is property-based, where you can say, okay, the roles for the actuator should be this, and this one is sensitive, this one isn't. And then if you need to bring your own customization on top of that, you need to look into 3 places to figure out what your security config is. Right now, what we do is we provide a default just for the sake of making sure things are secured. But very quickly, you'll have to provide your own config. And what we didn't want you to do is, because you have to provide your own config, all of a sudden, you have to redo everything the auto-configuration was doing, right? We didn't want you to do that. So what we've done is giving you providing some helper classes where you can very easily replicate what the auto-configuration does. So that's one, which is what you see on the screen. But 2, if you want to know about your security infrastructure, there is now one place where to look. So it's very obvious what your security infrastructure looks like. So in this case, what we're basically saying is we use endpoint request 2 to actually list endpoints. And if you remap those endpoints, so if you change if you change, for instance, the base path, so you don't want actuator, you want management, for instance, and you don't want status, actually it's a typo in the slide. It's not a typo, it's a typo in the slide because status now is Earth, but whatever. Oh, yeah. So let's say it's Earth, not status. If you want to remap that to, I don't know, my Earth for some reason, because you don't want the default path, this will take that into account. So it will take into account other customizations that you've done in your application. And the thing that you get is actually a Spring Security, standard Spring Security hook points. So the thing that you use after that is the regular Spring Security matcher. So you can anything you could do with Spring Security, you can do it here. So I'm saying Earth and info you can access. Any other from those, you need a role. So that's what management security roles used to be. I want to be able to access static resources. Again, that thing knows about the default path. And then you can start with your configuration, so your endpoint, basically.
Good. So speaking about security, now for our dashboard, because it's dealing with sensitive data, we'd like to at least have HTTPS in our application. So that's what we're going to do. We're going to configure HTTPS within our dashboard application. So it was already available with previous Spring Boot versions, but we'll show you a bit more. So if you need to configure HTTPS on your application, first you need a few configuration keys. So you need to tell Spring Boot where your key store is, the password or like secrets that you need to have to open the key store and to get the key. And of course, you need to provide a key store. So here in our case, we're providing a self-signed certificate. So it's expected that the browser will complain about it. But we're just setting things up to show you that we've changed the port as well. Yeah. So it's now 8.3, yeah, that one. So it's not secure, but we're still using HTTPS with that certificate. So it's pretty easy to set up HTTPS. We can even show the protocol, I guess.
Yes.
So in the network tab, we can see that it's HTTP 1.1 and using HTTPS. But with Spring Boot 2, we've added a new support that you can easily turn on with your application properties. And we can show what it is, actually.
Right, let's do that. Something called HTTP2. I don't know if you've heard of it.
Yeah. So if your key store and your keys are all right with regards to HTTP2, you just have to turn on that feature, and then you can see in the protocol tab that now our application is using HTTP2. So the thing is, here we're supporting HTTP2 for Jetty, Tomcat, Undertow, of course. So in the case of Tomcat, now our default right now is Tomcat 8.5, and you can use HTTP2 if you're on JDK 9+.
This app is running JDK 10, actually.
So you can still use HTTP2 with JDK 8 or later, with Tomcat as well, without using the JDK support of HTTP2, of the new TLS 1.2 support, you can actually use the Tomcat native libraries. So if you have the native libraries available in your in your JVM libraries path, then Tomcat will detect that automatically, and Spring Boot is doing the whole setup for you. So it'll use HTTP2 using the native support, which is more efficient, of course. And same thing for Jetty as well, where if you're using the conscript dependency, so if you're adding a few dependencies on top of the Jetty starter in your Spring Boot application, it will fetch native libraries, so conscript here to do the TLS support, and you'll have a super efficient HTTP2 support in your Spring Boot application.
Right. Breaking news: Spring Boot 2 OS GA. I'm sure you know about that. We have built a migration guide on the wiki. So if you've not upgraded yet, or if you're considering upgrading, there is really a lot of information in there. It can be overwhelming, but please keep in mind that probably 90% of the content does not actually impact your application. So you need really to focus on the things you're using. You can also get started on start.spring.io. Try to build the first reactive app and see how it feels like. And that's pretty much it.
Yep. Thanks a lot.